Hi and welcome to this video about serverless, DynamoDB and file structure. Today we will continue to build on a project from the previous video. Previously we gave our serverless application access to the Awesome Birds table. That's awesome, but wouldn't it be nice if we also could configure the DynamoDB table using infrastructure as code? Or more specifically, the serverless framework. That's exactly what this video is all about. Before we continue, if you find my videos interesting and want to learn more about serverless and AWS, please consider subscribing to my channel and smash that bell icon to get notified when I publish more content. So, to get started, maybe we should think about how we want to structure our code. Up until now, we have written all our serverless code in the serverless.yaml file. This is fine for small hobby projects, but will soon grow to be a large mess. Therefore, I'm now going to show you how I like to structure my serverless projects. I will not take credit for all this, as some parts is quite standard. Firstly, we can start by creating a serverless folder where we can create a YAML file for each of our Lambda functions. Then just copy the create_bird config from serverless.yaml to the create_bird.yaml file and do the same thing for the other Lambda function. But now that we have removed all the Lambda config from the serverless.yaml file, how will serverless be able to see where we have placed it? Well, we can just reference the files containing the Lambda function config in serverless.yaml like this. Under create_bird, write $, curly braces, file, and then serverless/create_bird.yaml. By referencing a file like this, serverless will find that file when deploying and use it to configure the Lambda function. For the other Lambda function, just reference serverless/getBird.yaml. Okay, so now we have a serverless folder where we have all the serverless config for our Lambda functions. But what about that DynamoDB table? Well, I like to create a resources folder for stuff like that. Mostly because resources like DynamoDB tables is not necessarily connected to just a Lambda function, but also that it has to be defined using CloudFormation syntax. So let's create a resources folder. Inside that folder, we can create a YAML file containing the CloudFormation syntax for creating a DynamoDB table. I will not go into how CloudFormation is used to create a DynamoDB table, so just copy the code from the GitHub link below if you want to replicate my setup. That being said, there are some things to consider. When it comes to the table name, it can be practical to reuse a variable name since we need this when creating IAM policies for our Lambda functions and inside the Lambda function code itself, as well as when defining the table itself, as we're doing right here. So, to create a custom variable that can be accessible for all these use cases, you can make use of the custom field in the serverless.yaml file. Just write custom and inside write your variable name, which in this case is table name, and then the value. I'll call mine birds-table-v2. Now we can go back to the table config and replace the table name with a reference to the variable like this. $, curly braces, self, custom.tablename. Now that we have the table name in place, make sure you have the ID defined as a partition key, as I have here. We also need to update the IAM policy for our Lambda functions. We want them to use our new DynamoDB table and not the old Awesome Birds table. In my case, the table names is the only thing that I need to change in the resource ARN. I will again reference the custom variable for our table name. There is a small change we need to do to our Lambda function code itself. We want to get the table name from an environment variable. This way, we can again reference the serverless custom variable instead of hard coding the table name. Inside the createBird lambda function, import OS, then create a field variable called tableName that uses OS to get the variable from the environment. Now remove the hard-coded table name and replace it with the field variable. And then do the same thing for the getBird lambda function. Now, the table name also has to be accessible as an environment variable in the first place. To do this, we can make use of the environment property inside the provider property in serverless.yaml. Just create a variable called tableName and reference the custom serverless variable. By defining variables under the environment property, you can create environment variables that are accessible for all the Lambda functions in this project. Oh, I almost forgot. We also have to reference the birds table.yaml file under resources in serverless.yaml. Otherwise, serverless will not be able to find the table config and the table will not be created. So, under the resource key, write a YAML list object where we reference the birds table config. I guess it's now time to deploy and test our application. Just write serverless deploy in your terminal as usual. Now that the application is deployed, it's time for testing. Copy the gateway URL from the terminal output. Go over to Postman. I want to test the createBird post endpoint first. So let's paste in the URL, set the HTTP method to post, and create a bird request object. Keep in mind that the only required field is ID since it's the partition key. And yes, the bird should now be stored in the database. To test this, let's copy the bird ID from the bird we just created and hit the get endpoint with that ID as a path parameter. And yes, we got the bird object in return. And to show you that this actually did connect to the correct DynamoDB table, we can go over to the AWS console, and here you can see that we have a new table, and inside this, we can see the object we just posted to our API. This means that we have successfully created a new DynamoDB table and connected two Lambda functions to it. So what's next? Well, in the next video, I will show you how to create SQS queues using the serverless framework and connect them to a Lambda function. If you have any questions, please leave a comment in the comment field below. And if you like this video, please give it a thumbs up. Until next time, happy coding!